A very good morning, everyone. I hope I'm audible.
Yes, ma'am. Good morning.
Yes, good morning, sir. So we are waiting for all other participants to join in, and we are going to start the session 10:30 sharp.
Sure. Thanks.
A very good morning, everyone. I, Dr. Rucha Lohi, welcome you all on behalf of Datta Meghe Institute of Management Studies to the Day 3 of AICT Atal Online Faculty Development Program on Quantification of Human Resource with HR Analytics. Today, for the first session of the program, our expert speaker is Dr. Saurabh Agrawal. Sir is a graduate and postgraduate engineer from IIT Kanpur and IIT Delhi. He is associated with HPTU Kanpur, Great Lakes, Gurgaon, AIMA New Delhi, and NMIMS Mumbai. He is a consultant to IBM and UNESCO for Business Analytics. He has published paper on integrating alternate payment channels and was presented in the 4th International Conference on Payment Channels organized by Bankit India, Mumbai. He has interest in data mining, data analysis, business analytics, structural equation modeling, multivariate analysis, and works on platforms like R, Python, SPSS, MOS, etc. Sir has conducted international workshops, trainings for reputed organizations around the globe. Sir, we are privileged to have you as a resource person for this FDP. Now I request Dr. Saurabh Agrawal, sir, to take over the session.
Good morning, sir. A warm welcome to you.
Yeah, good morning, ma'am. Good morning.
Yeah.
Yeah. So do I begin, ma'am?
Ji, sir?
Do I begin the session?
Yeah. You can start
Okay.
your session, sir.
Okay. Good morning, Shiny ma'am. Good morning to all the participants. Right. We'll begin this session on analytics. Right. And this is spread over 4 sessions, 3 sessions today and the 4th one tomorrow. And the whole concentration will be on what is basically analytics and what are the different tools which we have for doing analytics. Right. I'll keep it very interactive. Right. And all those who have any questions or anything like that related to your research or related to analysis, right, all of you are very free to ask, because this is the way I generally conduct the sessions, right? And any concepts you feel like asking as far as your research work, PhD thesis, or any thesis is concerned, or research paper, right, all of you are very free to have that kind of an interaction. So I'll begin with what are the different kinds of analytics which we have, right? And then I'll take you to some of the platforms on which generally our research scholars or people writing thesis are using. What are the different kinds of tools people are using? And then, as I said, any questions you have as far as analysis is concerned, as far as concepts are concerned, as far as tools are concerned, right, please feel free to interact. So let me start. Let me share my screen. Is my screen visible, ma'am?
Sir, we can see that you are sharing the screen, but screen is not yet visible. Yeah, sir, it is visible now.
Okay. So I'll start with what are the different kinds of analysis which we generally do, right? And what are the different tools which we have which people are using for doing the analysis. And then I'll expose you to different kinds of analysis and different kinds of tools which people are using for doing all these kinds of analysis. And then you can relate it to your research work, right? Anything you feel important, you can ask. So I'll begin with some basic concepts and what are the different analysis you can incorporate in your research work. So statistical analysis is the process of collecting and analyzing samples of data to uncover patterns and trends and predict what could happen next to make better and more scientific decisions. So this is the way you explain actually what is statistical analysis, right? You collect some samples of data from representing the population, right? And then the basic idea is to uncover the pattern and trends which are there in the data which you have collected, and then do some kind of a prediction, right? so that you are able to make a better decision. This is what actually you do when you are trying to do a statistical analysis. The whole purpose of statistical analysis is to uh, help the society in making some better decisions. That is where your research work should be applicable, or whatever you are doing as a part of your research work, that is where it should be basically used. Right. Now there are two words which are generally common. One is what you call it as the statistical analysis, and the other one is what you call it as the data analysis. Now people use these words interchangeably, right? But just to clarify, what is the difference when you write the word statistical analysis and when do you write the word data analysis, right, as a part of your research work? Right. And let me just put a small statistics also in front of all of you, right? See, all the academic institutions, they are ranked, and you must have heard of, there is something which is known as a QS rankings, right? Which ranks all the academic institutions around the globe, right? And the astonishing thing which has come out from this rankings is that you don't have a single institute in country which is in the top 300, right? Neither you have an engineering institute, neither you have a management institute in the top 300 in the country, right? That situation is because we don't have quality research, because one this is one of the key parameters on which the academic performance is evaluated, and this has degraded, right? 20 years back, when I studied from these two premier institutes, right, we were in the top 50, and in the last 20 years, we don't have anything in the top 300. The first one to enter is the Indian Institute of Science at Bangalore, followed by the IITs and the IIMs. So, what I'm trying to say is that the quality of the research is very, very important. Do some good quality research from which some patents can also be coming out from that research. And that is why we have started trying to understand the research in a better way and trying to use these tools, right? So when we apply all these statistics and tools, right, two things we do. One is the statistical analysis, where you draw something about the population from the sample of data which you have collected. And something similar to this is the data analysis, where the analysis is generally done for people who are non-technical. You need to convert whatever are your findings into something which these people can understand. So data analysis is more relevant for the industry, and statistical analysis is more relevant for the academia, right? The
Hello.
tools remains absolutely the same. The only thing is there is a change in the interpretation, because you need to interpret the
Hello.
way people understand, the way
Hello.
academia understands, and the way the industry understands. The second difference is naturally on the sample size. For a statistical analysis,
Hello.
generally the sample size is small, and for data analysis, the sample size is large. That is the second difference between when you use the word.
Sorry to interrupt, sir. Can you hear me?
Yeah, ma'am.
Can you please put it on presentation mode?
Ma'am,
Yes.
see, there are only
Hello.
5 or 6 slides only, ma'am. Right?
Hello.
Okay.
Changing
Okay.
the
Okay.
slides will be easy, ma'am. Right? I think it is
Hello.
visible. Right?
Some
So,
of the part of the text is missing, sir.
okay.
So in presentation mode, we'll be able to see the complete slide.
So that is the difference between a
It is already visible.
statistical analysis and the data analysis, right? Now once we have collected the data, right, what are the different kinds of basic analysis which you can do, right? Let me go through the basic analysis which you can do, right? And then we can see what analysis can be basically done. Unmute our phone. The basic analysis which you can do is, the first we start is the descriptive analysis, right, where you deal with the descriptive parameters like mean, median, mode, quartile, kurtosis, skewness, right? You tell all these parameters on the data which you have collected, but then these are not just mathematical values. you need to interpret what actually you mean by these values and what they are trying to tell about the data which you have collected. So whenever you start writing a research paper or a thesis, right, the first thing you do is the descriptive analysis, right? Descriptive analysis, you do it numerically, and the descriptive analysis, you do it using some kind of a visual presentation where you draw different kinds of graphs: pie chart, bar chart, clustered bar, histogram, frequency polygon, right, box plot, heat map. These are different kinds of plots which you actually draw, right, which gives you some idea about the data which you have collected. So this is the way actually you write or begin telling the kind of data which you have collected. So there are two things you do. The first is the descriptive analysis, numerically, right, telling what are the different statistical parameters and how is your interpretation about the values. And the second is you present your data visually using a number of graphs which are available, right? When I'll go through the analytics part, I'll tell you how to get this descriptive analysis and how to get the visual presentation. But this is what will add quality to your research paper, right? This is what will add quality to your research paper. The whole intent is to make your research look good. That is what my concentration has always been, right? How can you make your research look better quality? So the first thing you do is the descriptive analysis, which you do both numerically and using some visual. The second one is the inferential statistics, right? Where you try to draw some inference about the population from the sample of data which you have collected. And this is what is generally known as testing of hypothesis. Every research paper will have some kind of a hypothesis formulated, and then the testing of hypothesis is done. The only thing is, people there are people who can't even write the hypothesis. There are people who cannot find the test to do the hypothesis, and and there are people who cannot interpret whatever values you get from testing the hypothesis. So I'll go through this inferential statistics, how it actually is done on a data which I'll share with all of you, right? And maybe if possible, you can also do it with me, and so that you are clearly through the concepts. But testing of hypothesis is something which is common for most of the research papers. But the part which is not good is people don't do justice to how the hypothesis is tested. People are not able to formulate the correct hypothesis, and people are not able to test the hypothesis. So that is what I'll concentrate on. The whole issue is, how can I make your research look the way it is expected to look, right? And these are some of the ingredients which I'll share with you, because uh, the way I give my comments on the different research papers, I'll tell you, right? Because now, if you really want to publish your research in a good journal, there are a number of things which you need to keep in mind. That is what also I'll discuss as we move forward. So the first is the descriptive statistics. The second is the inferential statistics. The third one is what we call it as the predictive analytics. Right now, the next one I move to is what we call it as the predictive analytics. Right now, when you have collected some data, every research will involve some kind of a prediction, and there are many different formats of prediction which you can do, right? Every research paper will have one component as the predictive analytics, where you are trying to do some kind of a prediction. So this is what also we'll understand, right? How, what are the different algorithms, what are the different analysis which you do, which come under the umbrella of predictive analytics, right? I'll take up those analyses which are generally common for every research paper, and then I'll tell you something which is unique to different papers. So the first one is what
Participants,
you call it
please
as
mute yourself.
the first one is what you call it as the descriptive analytics. The second one is what you call it as the inferential analytics. The third one is what you call it as the predictive analytics. Now, after predictive analytics, the next one is what we call it as the prescriptive analytics. right? Now this prescriptive analytics may not be a part of every research paper, because this is even more complex than a predictive analytics, because it answers a very specific question: what should be done next? Like I'll say, a doctor gives you a prescription, he doesn't gives you a prediction, right? So if you go into even a more even a prediction which answers a very specific question, what should be done next, then that is where a new kind of analytics comes into picture, which is what we call it as the prescriptive analytics, right? I'm just trying to tell you what are the different analysis which you can do in your research paper. Very broad analysis. Under each heading, you have lots to do. You can do lot as far as your research is concerned. So you start with descriptive, then go to inferential, then go to predictive, then go to prescriptive, right? And let us see what are the other ones which we have, right? So we have the predictive, we have the prescriptive, right? Then we have something which is known as the exploratory data analysis, or EDA, in which you try to focus on the kind of distribution your data has, the kind of missing values your data has, the kind of outliers your data has, and whether what is the kind of correlation between the variables. That is what you do as a part of exploratory data analysis. You try to explore the data which you have collected on various statistical parameters, So this question also I'll try to answer on the data which I have collected, right? So you start with, again I'll say, descriptive, inferential, predictive, prescriptive, then you come to exploratory data analysis. This may not be the sequence, but this is what is required in every research paper. Then you try to study some kind of a causal analysis. This is where you study the kind of correlation between the variables, right? And I'll tell you that uh, how correlation is important, between the variables. If it is less, then also an issue. If it is more, then also it is an issue. And how do you take care of these correlations between the variables? So these are
Sir,
very
your screen is not visible properly. Please see it.
okay. So these are the different kinds of analysis which you do in your research paper, right? You start with descriptive, you come to inferential, then you come to predictive, then you come to prescriptive, then you come to causal, right? And then you come to exploratory data analysis, right? These are just the few names which you remember, which will help you to identify what are the different analyses which you can incorporate in your research paper. Right? These are just a few slides, right? Which where the focus is to tell you that what are the different kinds of analysis which you can do. Now, to do all these analysis, you must have heard of a number of tools which people are using as a part of these analysis. Now, just to interact with all of you, I'll ask you a few questions, right, so that you are also involved in the discussion, and the discussion is useful for all of you, right? So, I'll just write down a few things now. The first is, what are the different tools now for doing all these different analysis, right? You have a number of tools which are available, right? And to make your research look good, right, you need to use these tools for analysis. Now can a few of you just speak a few of the tools which you are using, or you intend to use, right, or which you have heard of as far as the analysis is concerned? Can I have a names of few of the tools?
So my
Excel,
question was
Excel,
software.
SPSS,
Tableau,
Okay,
SPSS or
So
Tableau.
Excel,
okay, fine enough.
Toolpack.
ANOVA
And
teaches.
these are the analysis, right? So the tools,
Sir, SPSS are Excel.
yeah. So tools which are used for analysis, which you can use for analysis, and you can incorporate the results from these analysis, right? So there are, these tools are basically under two groups, right? This is from where I'll begin from. these tools are basically under two groups, and my concentration will be basically on how do you actually use all these tools, right? So I hope it is visible to all of you, right? So one is what you call it as
Yes, sir, it is visible.
one is what you call it as the license tools, right, in which you need to have a license to use these tools. And the ones which comes to our mind is, one is the IBM's SPSS, which I'll start with. The second one is uh,
Amos,
Lisrel,
NVivo,
right? And you have
Smart PLS,
Statistica, MATLAB, Data, right? These are all the licensed tools which people have, which people use depending upon the kind of access you have, right? The limitation of these tools is that you need to have a license first, and then maybe there are something which you cannot do on these tools. That limitation is also there. But the beauty of these tools are that most of the tools are graphical user interface menu driven, right? So using the tool is not very difficult. Using the tool is not very difficult. Today, I'll expose you to both the licensed tools and the open source tools. The second one is the open source tools. And the two most popular open source tool people use in their research work is R and Python. R and Python, right? So I'll expose you to the most popular license tool, which is the SPSS, and then I'll expose you to the two open source tools, R and Python, because I use these tools for doing my analysis, right? Now, the beauty of R and Python is because you should know both sides of the story, and then you, as a research person, can decide which tool to use. The open source tools are the two most popular open source tools are R and Python. The advantage of the open source tool is that you don't require any license, right? And you can download it from the net and then start using it, right? I'll also give you the link, right? All those people who want a link, right, from where they can download this open source tools, right? I'll just write my email ID, right, where all of you where you can just put in your requirement. So I'll just share the link to download both R and Python, right? I'm just putting it in the chat box because all those who need it, they can request and I'll give you the link, right? So that it is not for everybody, because maybe everybody is not interested. So I am not uh, pressurizing everybody that they use this tool. So this is my mail ID. All those people who want a link, right, to download R and Python, they can send me a mail, and I'll put the link from where you can download it. From where you can download it. Now the beauty of the open source tool is that you don't require any license, right? And you can download it from the net and start using it. The second advantage is you can do anything what you can think of. The third disadvantage is that it requires some small scripting. It is not completely menu driven. But believe me, right, writing those scripts, writing those codes are very, very easy. Right. Last yesterday only I was conducting a session, right? And I'll really tell you the way people understood writing the code, it was fantastic, right? So some people think writing a code is very difficult. It is absolutely not, right? And that is why people have the option to go in for either SPSS or for R or for Python. The only thing I'll say is that now some of the journals, like, because I review a number of papers for some journals, now they are trying to put this limitation also, that what should be the tool which you should use for analysis. And I'll tell you a number of things which are now being incorporated as a guideline, right, when you start doing your research. So today and tomorrow, I'll give you a flavor of all these tools. The basic reason is that you are in a better position to decide which tool to use. I'll do the same thing for in SPSS first, then I'll do it in R, and then I'll do it in Python, right? And make you all comfortable so that you are in a better position to decide, sir, which one to go in, weighing the pros and cons of each of the tool. The commonness is that you use either of the tool, the answer will remain the same. The statistical values will remain the same, right? Irrespective of whether you use SPSS, R, or Python, because the basics don't change. Because the basics don't change, right? So this is the way you can think of. You can think of which tool to actually use. Now let me first start with, and then maybe you can better appreciate which tool can be basically used. Okay. Now before I go on to using the first tool with the different kinds of analysis, right? Any basic question anybody would like to ask? Since you are a large number, right? Anything which comes to your mind? Okay. Now, the first thing is, once you start doing the analysis, right, is the nature of the variables. Nature of variables. Yeah.
I would like to ask about, sir, SPSS license copy or AMOS, where we will get?
See, SPSS is a licensed application in which SPSS also comes in number of flavors. The one which I'll be showing today is the SPSS Statistics. Then you have SPSS AMOS, right? All these are different applications, right? And these applications, if you want to use it, you should have a licensed copy of it. You cannot download it from the net. You cannot download it from the net. You need to have a licensed copy before you can use these applications. But if you are interested to use R and Python, right, I'll give you the link from where you can download it, and it will take hardly 5 minutes to install. And once these two are installed, you can do the same thing in R and Python without going in for any license.
So, sir, then structural equation modeling, is it possible in R or Python?
Structural equation modeling is also possible in R and Python. We do it regularly in R and Python.
Okay. So, sir, then is it any book or manual is available for that? How to use it R and Python for structural equation modeling?
You have lots of literature available on the net, ma'am. You can just put in using structural equation modeling in R. You will get a number of books where you can which you can refer to and see how can you use structural equation modeling in R and Python.
Okay, sir. Okay.
So anything which you can do in SPSS Statistics or in SPSS AMOS, right? You can do the same thing in R and Python, but it is not the other way around. There are a number of things which you can do in R and Python, which you can do in SPSS Statistics.
Participants, kindly mute yourself, please.
Comparatively between other subjects, language compositions are matching.
Okay. Now, before you start doing the analysis,
Subjects, English, Hindi, and maths.
see, whatever you speak a little loud, and other people can mute.
In totality. Oh, sir, male teacher.
Now,
Saurabh sir, you can mute that participant, sir. As you are the host, you can mute that participant.
वो मैडम आप म्यूट कर दो because finding it will be very difficult. नहीं तो मेरा time
Okay, sir. Sir, because you are the host, I am not able to mute it.
I will make you the co-host, na?
Okay, sir.
Yeah, but just take care that there is no background noise. Otherwise,
Yes, sir. No, yes, I'll take care of it.
and anybody who raises the hand, you can unmute them and they can ask the question. Right. Okay, now once you start doing the analysis, there are two kinds of variables which you should remember. Right? That
इंग्लिश और हिंदी में हमें सबसे
two
कम
kinds of variables are,
I've
the
been
first
telling
is a
you that.
numerical variable.
देखो languages से तो मैंने
Sumana ma'am, please mute yourself, ma'am.
First is a numerical variable, right? See, there are many people who don't appreciate the nature of the variables, right? So I just want all of you to appreciate the nature of the variables on which you collect the data. The first one is what you call it as the numerical variable, right? These numerical variables have basically, they are measured on two kinds of scale. One is the interval scale. One is the interval scale, and the other one is what you call it as the ratio scale. See, unless until you don't understand the nature of the variable, there is nothing you can do, right? I have seen people doing something which is not required. You find a mean of a variable like gender, right? That is something which is unwanted, right? You don't understand either the variable or you don't understand the statistics, right? This is what makes your research paper of a poor quality, right? So आप लोगों को इन बहुत छोटे, you need to pay attention to all these small things before you can make something valuable or something good in your research. Now, first is a numerical variable, and this numerical variable is generally collected on two scales. One is the interval scale and one is the ratio scale. So I'll just give you an example. For the ratio scale, we have variables like marks, height, weight, right? They are all examples of your ratio scale. I can say a student scoring 80 marks has done twice better than a student getting 40 marks. Then interval scale is like you have a variable temperature. See, I come from an engineering background. For me, the temperature variable is very important, right? Because lots of my data is collected on this variable. Temperature is not a variable which is on a ratio scale, which generally people use it, right? So temperature is an example of a interval scale, is an example of an interval scale. And we have so many variables which are measured on an interval scale. You don't say a 44 degrees centigrade temperature is twice hotter to a temperature of 22 degrees centigrade, because the variable is measured on an interval scale, and that is the kind of interpretation you cannot do. There's a different set of statistics for a variable measured on interval scale, and there's a different kind of statistics on a variable measured on ratio scale. There are many research papers where people have not understood the nature of the variable, the scale on which the data is collected. And once you don't understand what is the scale on which the data is collected, you will not be able to do the justice on the analysis. Because every analysis is meant for a different kind of a variable, The first set is the numerical variable, which is measured either on an interval scale or it is measured on a ratio scale. The second set of variables you have is what you call it as the categorical variable. And you have lots of variables on which the data is collected, which is categorical in nature. Again, there are two scales on which a categorical variable is measured. The one is the nominal, and nominal like we have gender, type of program, right? What is the kind of program he is doing in my university or college, whether it's a UG program, PG program, or a PhD program, right? What is the socioeconomic status of the student, right? These are all variables which is collected on a nominal scale, right? The second one is what we call it as the ordinal scale. The best example of an ordinal scale is the data which is collected on a Likert scale. The data which is collected on a Likert scale, right? So you say my data is collected on a scale of 3, strongly agree, neutral, strongly disagree, or a scale of 5, strongly agree, agree, neutral, disagree, strongly disagree, right? Now this is what is a Likert type scale, and this is considered to be ordinal in nature. There is absolutely a different set of statistics for a variable which is measured on an ordinal scale. I've seen so many people calculating the mean of a data of a variable which is measured on a Likert scale, which is absolutely wrong, because that mean doesn't tell you anything about the nature of the variable. So many research papers where people are calculating the mean of the variable which is measured on a Likert scale, which is absolutely wrong, because technically you cannot calculate a mean, and that mean will not tell you anything. That mean will not tell you anything, right? So what I'm trying to tell you is, first you identify what is the nature of the variable which you have collected. Is it a numerical variable or is it a categorical variable? If it is a numerical variable, what is the scale on which you are collecting the data? Is it an interval scale or is it a ratio scale? This will go a long way when you try to do the analysis. And if you have collected the data on a categorical, with a variable which is categorical in nature, then you can again have two kinds of scales. One is a nominal scale and one is an ordinal scale, right? Nominal scale, like gender. What is the kind of program he is doing? What is the socioeconomic status? What is his occupation? What is his salary bracket, right? These are all nominal variables. Then ordinal. Ordinal, where you have some kind of a rating, right? Suppose I ask a question, rate the mobile operators in your city. One respondent says, 1 is Jio, 2 is Vodafone, 3 is Airtel. That is the rating scale. You are trying to rate, or you are trying to say which is better than the other. But what you cannot say in the ordinal is how much one is better than the other. How much strongly agree is better than agree. How much agree is better than neutral. This is what you cannot say. That is why such kind of a variable is measured on an ordinal scale. Now, once you decide, okay, this is my data and this is the scale on which the variable is collected, that is the way you will do the entry either in SPSS or in R or in Python. I'll tell you one by one how this is to be taken care of, first in SPSS, then in R, and then in Python. Right? Because if this foundation goes wrong, then there is absolutely no need to do any analysis, because your analysis is built on this foundation, which you don't appreciate, right? So pay lots of emphasis on what are the variables on which you have collected the data. Naturally, the variables will come from the literature review. I'll not go into the literature review because my talk is basically focused on the analytics. Otherwise, I could have gone into the literature review and sampling part also. But let me concentrate on the analytics, which is more difficult compared to these two. Right? So you need to identify on what scale you have collected your variables. Right? I'll repeat again, right? Because if this is what goes wrong, right, everything will go wrong. And you will also never get to know, right, what has gone wrong, because you never understood on what scale the data was collected. So I'll just repeat, in our research or in our analytics, there are only two kinds of variables. Either the variable is numerical in nature or the variable is categorical in nature. Now, any tool you use, you need to specify if it is numerical, whether it is on an interval scale or is it on a ratio scale. If you don't know, then you ask somebody, right? But don't take anything for granted. Don't take anything for granted, right? Now, the second set is a categorical variable, right? Categorical variable is like gender, boy, girl, male, female, kind of program he is doing, right? You need to tell exactly the nominal. Don't calculate the mean of a nominal variable. That doesn't tell anything. I've seen many research papers, people have calculated the mean of a nominal variable, which is absolutely wrong. Then you have a variable which is like ordinal. There are so many research papers where people develop some kind of a measurement scale in which all the questions are measured on a Likert scale. And people do lots of statistics on that Likert scale, which is not required. People don't know that they are calculating the mean of a Likert scale, which is absolutely wrong. Right? So that is why my emphasis was on trying to make you understand that the first step you need to do is to identify on what scale your variable is measured. Now, once you have identified the scale on which
Sir, I have a question. Can I ask?
Yeah.
Sir, I just wanted to ask that if suppose we are collecting data about age and it is like whether you fall in the 30 to 40 years ka bracket or 40 to 50, will it be interval scale or will it be categorical?
It will be categorical, man. So first you decide whether you will collect age as continuous, numerical, or will you collect it in the bracket, right? So if you want to collect it as a numerical variable, you can just write age and then write age, right? The other way is you can make 4 or 5 categories, 10 to 0 to 15 to 30 years and so many, and let the person pick on the required category. If you are doing it this way, it is a categorical variable. It is a categorical variable. And if you are doing it in the first way, right, then it is the numerical variable which is measured on a ratio scale. Right. Now the automatic question is, sir, which way to go in for? Because that is the next question which all of you like to ask. Should I collect the age as a numerical variable or should I collect the age as a categorical variable? The answer to this question is that will depend largely upon, right, what is the kind of objectives which you have formulated. Right. So many people I have seen, sir, I don't know. Right. I collect age as continuous. They don't have any solid background for it. So the way you will collect the variable age will largely depend on what is that you need to do with the variable like age, right? So it can be collected either numerically or it can be collected either categorically. If you don't know, then it is better you collect it numerically, because numerically can be converted into categorical, but categorical cannot be converted into numerical. Categorical can be converted into numerical. Yeah.
Sir, I have a question. Suppose if we are having a data of strongly agree to strongly disagree at 5 level scale, strongly
Just be a
disagree
little loud, man. A little loud, man. Yeah.
Sir, suppose if we are having a data strongly agree to strongly disagree, 1 to 5 scale, right? 1 to 5 scale level pen. So some books are saying that it is an interval scale, and some books are nowadays I am referring that they are saying that it is an ordinal scale. So
I'll tell you the difference. I'll tell you the difference. See, if you are using numerical values 1 to 5, right? If you are rating it on a scale of 1 to 5, then it is interval. And if you just write it as strongly agree, that the way you present it in your research paper or the questionnaire in which you have collected the data, if in the questionnaire you are using a scale of strongly agree to strongly disagree and asking the respondent to tick on that, that is an ordinal scale. But if you are saying, if you are not using the word strongly agree, and you are saying, right, kindly do it on a scale of 1 to 5, where 1 is so and so, 5 is so and so, then it is an interval scale.
Okay.
So that depends upon the way you have designed your questionnaire. The way you have designed your questionnaire, right? The interval scale is numerical and ordinal scale is categorical. The commonness is between any two categories or between any two levels, you don't know how much one level is better than the other. That is the intrinsic property of a variable which is measured either on an ordinal scale or measured on an interval scale. But it solely depends upon the way you have designed your questionnaire. और आपको ये सोचना चाहिए whether I should collect it on a numerical scale of 1 to 5 or should I collect it on a Likert scale of strongly agree to strongly disagree. That thing.
So once we are taken it, sir. So once we are taken it as a interval scale, so we can proceed with the parametric analysis. No, so parametric data analysis by using property test or multiple regression, so Pearson correlation. We can proceed on that line, no?
You don't do all this on a data which is collected on an interval scale, man. This is done on a data which is collected on a ratio scale. Do not do parametric and non-parametric test on a data which is collected on an interval or an ordinal scale. That data is not meant for all this. If you collect a data which is on an interval or an ordinal scale, the intent is a little more different. The intent is not to do a testing of hypothesis. Otherwise, you will also do the same mistake which most of the people have committed in their research papers. आप books पढ़ो. I'll tell you the names of a few good books which you read, and that is what will make your concepts clear, right? That is what will make your concepts a little more clearer, because the nature of the variable will go a long way in deciding. आपका question बहुत अच्छा है, because this is the question which is the difficult one to answer, right? But you don't do regression, you don't do testing of hypothesis on a variable which is collected either on an interval scale or on a Likert scale. Please don't do it, because you will also commit the same mistake which the other people have done. When I'll demonstrate the testing of hypothesis, I'll tell you the nature of the variables which is used for doing testing of hypothesis. And you will find that the variable will not be on a Likert scale or on an interval scale. I'll just go through that demonstration, which will make you a little more easier for you to understand. So, आपका question बहुत अच्छा था, very relevant to the research which you do, right? But please don't do testing of hypothesis, parametric test, non-parametric test, linear regression, correlation. These are not meant for a variable which is measured either on a Likert scale or on an interval scale. That is the bottom line. That is the bottom line, right? Now, once you have decided what should be the nature of the variable, right, on which you have collected the data. बहुत से लोग हैं, they make the questionnaire, they collect the data, and they don't pay emphasis to why I have collected this variable on a Likert scale. They don't have any answer to that. That is what is not required. You should know, why have you collected this data on an ordinal scale? Why have you collected this data on a nominal scale? इसके पीछे आपकी क्या reasoning है? That is what will make your research a good quality research, right? And my emphasis is always that you do a good quality research because you are using some sophisticated tools like SPSS, R, and Python, right? The only thing is you need to do justice on the nature of the variables on which you have collected the data, right? The nature of the variables will go a very, very long way, right? आज के बाद आप इस चीज को appreciate करोगे, मेरे session के बाद आप ये appreciate करोगे why the nature of the variables is very, very important, which most of the people don't pay emphasis to, right? Now, once we have decided the nature of the variables, let me start working on a data set, which I'll start with SPSS and gradually I'll move from to R and Python, right? I want to show you the entire picture. I want to paint the entire picture. This is the way you work. Now, then I'll leave it to you, right? You pick up any tool which you feel is in which you can work confidently, right? I've told you the pros and cons of each tool technically, and more you will get to know when you actually start using it, right? And anything which you want to ask as far as the usage of the tool is concerned, right? I have shared my mail ID. You are all free to put in your query. I'll try to answer, right, your query. Now let me come to SPSS, right? Now this is the opening screen of SPSS, which all of you must have seen, right? The beauty of SPSS in short is it is a graphical user interface, right? And you can use the menus and then do the analysis. In short, this is the beauty of SPSS, right? And that is why it is very popular as far as the academia is concerned, right? But not many people use it in the industry because of so many reasons. Now, this is a data which is collected from a university, and I'll show you how different analysis can be done on a set of variables on which the data is collected, right? So, the two views which you have, if you see, is the data view and the variable view. The data view is the data which is collected from the respondents, and each row corresponds to one respondent, right? So as many is the sample size, as many will be the respondents. Now the thing which is more important is the variable view, in which you tell everything about the nature of the variables. So I'll tell you how do you create a variable in the variable view, right? What all you need to remember in creating the variable, and then you can use the same philosophy and then create all the variables on which the data has been collected, right? The beauty is, if you do it right in SPSS, you can import the same file in R and Python. You don't need to recreate the variables and the data again in R and Python. Suppose you want to do something in SPSS and something which is not in SPSS but required in your research, you can switch to R and Python. When you switch to R and Python, you can import the same data set which you have in SPSS to R and Python. That is the beauty, right? And I'll tell you how can you import the same data set into R and Python. So the creation of the data and the creation of the variables has to be done only once. Has to be done only once, right? Either you do it in SPSS and then you can import it in R and Python, or you can make it in R and Python and import it into SPSS. Please don't waste time in doing the same thing in either of the tools, right? That kind of connectivity is there between all the three tools, Now let me tell you how one of the variables is created in SPSS, and then you can follow the same logic in creating the data, right? I'll share this data set with all of you today, right? And I'll expect all those who have SPSS, they do the same thing and share the SPSS file with me, right? So that I can tell if there is something wrong in creating the variable view, right? This variable view is very, very important, right? Because once you start, like when I do the physical workshops, many people say, sir, the data was the same, but why am I getting different answers? That's a very logical question which the people or the attendees ask. The reason is the data is the same, but there is a difference in the variable view. And that difference in the variable view is giving you different p-values when you do the same thing in different, but done by different students. Now, suppose I need to create a variable like gender. The first thing you do is to give a name to the variable. So I have written the name as gender, right? So let me tell you the entire process of creating a variable, and then you can use the same process to create the same variable, to create different variables in SPSS. The beauty is, once these variables are rightly created in SPSS, and you want to do something in R and Python, you can always import this file, and you don't need to recreate the variables, and you don't need to recreate the data. Just import that file into R and Python, and then start doing the analysis which you are not able to do in SPSS. Right? Like I work in the, I basically come from an engineering background. So we have a different set of analysis, and we generally don't use SPSS because we require tools which are not there in SPSS. But people coming from management, social sciences, tourism, they can all use SPSS because most of the things they require are present in SPSS. The second is, what is the type of the variable? So if you click over here, you will get number of types. So if your data is a number, you can use the type as numeric. If your data is a combination of a number and an alphabet, then you can use it as a string. If your data is reflecting a date or a time, you can use the option as date, right? So you need to tell what is the type of the data which you have collected. Is it numerical? Is it string? Or is it date? These are the three basic types of data which you will encounter. Suppose somebody is doing an exercise on, he comes from a finance background and he's trying to develop a model to predict the stock prices. Then one of the variables will naturally be a date, because you are collecting the stock price every day, right? So the variable type is very important. So since my data is numeric, I have selected the data type as numeric. The name of the variable should not be more than 8 characters, and it should not have any blank spaces. Keeping in mind, I may be using the same data set in R and Python. So don't keep the name of the variable more than 8 characters, and don't leave any blank space while defining the variables. So the variable name is gender, the variable type is numeric, right? Then I need to tell whether the variable is categorical. So there is a section like values. where I go and say that my value is 0 and my label is a male, and my value is 1 and my label is a female. The moment you do it, SPSS will understand that this is a categorical variable which has two categories or two levels, 0 for male and 1 for female. Whatever code you give for male and female is irrelevant. You can give it as 0, 1, 1, 0, 10, 20, 100, 200. The statistics will not change. But your data will be in the same coding, the way you have described it under the values. So the next thing is values in SPSS, which basically tells whether your variable is categorical or your variable is numerical. I have seen so many SPSS files where people don't define a variable with category and then they use it as a categorical variable. So the values is very important. This tells SPSS that your variable is categorical in nature. Then what is the measurement level? If you can see, the measurement level again is nominal, ordinal, or scale. You collect it as nominal. Gender is a variable which has two categories, 0 and 1, and the measurement level is nominal. And the measurement level is nominal. Next is you can give a label to the variable and describe what is your variable, right? This can be more than 8 characters with a blank space. This can be more than 8 characters with a blank space. Next is two more important thing is what is the width and what is the decimal. The decimal means, right, whether your variable is continuous or discrete. Now gender is discrete, either 0 or 1. There is nothing between 0 and 1, so decimal is 0. The decimal is 0. This is trying to tell that your variable is discrete in nature. Your variable is discrete in nature. And then what is the width? Width is how much space should be allocated in the memory. So I have a single digit number, 0 and 1. So width will be 1. Width will be 1. All this is very important if you want to do the correct analysis. And because if your variable view is not correct, you may get a different p-value. And this is what happens generally in a physical class. The most common question which most of the people has asked is, sir, you have shared the same data set, but why are we getting different p-values in testing of hypothesis? The reason is there is a mistake the way you have defined the variable in the variable view. That needs to be corrected. The moment you correct it, you will get the correct p-value. So the things to remember as far as the variable view is concerned, first, the name of the variable, which should not be more than 8 characters without any blank space. The only reason to do this is you have a compatibility if you need to import the same data set into R and Python. A person using only SPSS may not stick to this rule. A person using SPSS may not stick to this rule. The second one is what is the type of the variable? Since my variable has numbers 0 and 1, so my type is numeric. My type is numeric. Then to tell that it is a categorical variable, I go to values and then describe what is 0 and what is 1. Right? This tells SPSS my variable is categorical and the measure tells that I have measured this variable on a nominal scale. Then since it is a discrete variable, the number of decimal places is 0, and since it can hold a single digit number 0 and 1, the width is 1. The width is 1. The last thing is how to take care of the missing values. Values which you are not able to measure or which you couldn't get, right, is how do you take care of. This is what is known as missing values. So you go to missing and you define a discrete code as 9. Suppose for gender, right? Now, wherever you don't get a value for gender in the data view, suppose you don't know the gender for this case, you don't know the gender for this case, don't leave it as blank as in Excel, right? Put a missing value code which we have defined in the variable view. So put it as 9. This is the way SPSS will understand that this data couldn't be collected and the reason for not collecting the data could be anything. This is what is known as missing value analysis. that you incorporate and tell SPSS that for these cases and for these variables, the data could not be collected, and you do the calculations accordingly. You do the calculations accordingly, right? So this is the way you incorporate something which is known as a missing value, right? Using the same logic, you need to create the variable view for all the variables on which you have collected the data, right? So I'll be sharing this data set with all of you, and I want that all of you will create the data and the variable view in SPSS, and you mail me on the email ID which I have shared with all of you, right? This data set will be shared by me, and it will be emailed to all of you, or if there is a group, it will be put on that WhatsApp group. The exercise which I want all of you to do is, if you have access to SPSS, is to create the variable and the data view so that you feel confident that my structure of my data is correct. This is known as structure of data, right? And I really tell you, if the structure of data is not correct, right, then you will never be able to get the correct p-value on which your complete interpretation is based. हो सकता है जो null hypothesis आपकी accept होनी हो, if there is a null hypothesis which has to be accepted, which you think should be accepted, it is getting rejected. The reason is you are not able to create the correct variable view in SPSS. So you need to take care of the name of the variable, the type of the variable, the width, the decimal, the label, the values, the missing, and the measurement of the variable. All this should be correct for a single variable, and it should be correct for all the variables which you have considered in your study. The second point is, once you have created the variable and the data view in SPSS and have saved the file, you can import the same file in R and Python. You don't need to do anything extra as far as importing the data set in R and Python is concerned. And this is where you will save lots of time, because you don't need to recreate the data in any other tool. You don't need to recreate the data in any other tool. Any questions? Any questions? Anything which you have not understood? Anything which you find relevant to your research paper and you want to connect on that? Will you be able to create the data and the variable view if I share this data set with all of you?
Yes, sir.
Okay. So this is the exercise I want all of you to do, right? This is the data set I'll be sharing with all of you. And the first exercise I want all of you to do is to create the data and the variable view in SPSS, right? The reason is that once it is created, we'll be able to do a number of analysis which I'll be doing for all of you, trying to tell you how to formulate a hypothesis, how to test the hypothesis, how to do a prediction, how to do a correlation, how to make a graph. This is what all I'll be telling you, right, as far as SPSS is concerned, and then how to use the same data set in R and Python. How to use the same data set in R and Python. So that will make the scenario completely transparent, completely clear that this is the way a single data set can be used across the three tools for different kinds of analysis. But do remember that you create the correct data and the variable view in SPSS. Correct data and variable view in SPSS. Okay. Next is, now with this data set created in SPSS, right, with the data set into SPSS, what analysis can be done? What analysis can be done to answer some of the objectives in research paper. The first I'll start with, because that is what most of the research paper will have, is formulation of hypothesis, formulation of hypothesis, formulation of hypothesis, and how to test them, how to test them and get the correct, how to test them and get the correct p-value. Right. Now, if you can see on my screen, this is the data set which I have. I have a variable like gender, which is categorical in nature, and I have a variable like read, which measures the reading competency of the student before he took admission in my college. So I have the data set for gender, I have a data set for race, for socioeconomic status, for the kind of school he has attended before entering into my college, what is the kind of program he is pursuing in my college, whether UG, PG or a research, and then the competencies in a few of the basic traits, his reading competency, writing competency, science, maths, and the social science competency. Now I want to do a number of hypotheses, and their results will give me a lot of insight into the kind of students I have in my college, and maybe these interpretations will help me to take some very important decisions as far as the academic environment in my college is concerned. This is the way people are collecting data and doing the analysis, which is leading them to take some very critical decisions, right, which needs to be correct. So I have a variable like gender and I have a variable like reading score. On these two, I'll make the first hypothesis, right? So there are basically two kinds of hypothesis which you have, right? A null hypothesis or H naught. I'll just write it once and then you need to write it yourself. That also I'll give you an assignment today. If you do it, that will be a wonderful learning for all of you, right? Now, null hypothesis is that there is no significant difference. There is no significant difference in read competency between male and female students. This is the way you write the null hypothesis. Writing hypothesis is also scientific, and this is the only way you write the null hypothesis. Right. Now, the next one is the alternate hypothesis, which you will write in your research. So let me copy paste it to save time. Right. So this is my alternate hypothesis. So my alternate hypothesis. And this is referred to as HA. There is a significant difference in the read competency between male and female students. Now I need to do some analysis, and either my analysis should tell me whether I'm accepting the null hypothesis or I'm accepting the alternate hypothesis. Am I doing the null hypothesis or the alternate hypothesis? Right. Now the answer which you get will decide. If I accept the null hypothesis, that means there is no significant difference in the read competency between male and females. And if I am accepting the alternate hypothesis, that means that yes, there is a significant difference in the read competency between male and female. And then the management of the college can take a decision based on the research findings which you have on the hypothesis which you finally accept, whether it is the null or it is the alternate hypothesis. But before you can do that, right, you'll have to go through a long process in deciding the test. You need to go through a long process of deciding the test. Ma'am, can I continue or what should I do?
Sir, we can start the next session and then you can continue. Will that be okay? Saurabh sir, can you hear me?
Should I continue or should I take on the at 11:30?
Sir, we can continue in the next session,
Acha.
12:30 to 1:30,
Okay. Okay.
right?
Right. As you say, I'll stop here and we'll continue testing the hypothesis. Meanwhile, anybody has any questions, you can ask. If you want to ask any question, you can ask. Otherwise, I'll continue from 12:30 as.
Hello.
Yeah, ma'am.
Sir, can you suggest some books so that we can read and clarify our doubts regarding that
There's one good.
Likert scale and
The name of the book is Discovering Statistics. It's a very good book. Discovering Statistics using SPSS. Now, this book you will find for every tool, but since I am using SPSS, I'll say, and the name of the author is Andy Field. It's a Bible. It's a wonderful book, right? It gives you a lot of concepts as far as research and using those tools in SPSS is concerned. You find this book for every tool. You'll have this book for R. You'll have this book for Python. But
So,
book
sir, what's the name of the author?
Andy Field, ANDYFIELD. So you can, all of you can download this ebook. This ebook is available on the net. PDF version is available on the net. You can download it.
okay, sir. Thank you.
It's a wonderful book, and it gives you a lot of understanding on how actually you do the analysis on the data which you have collected, right? So that will make your fundamentals clear.
Okay. Sir, any reading material for clarifying doubts regarding what should be considered as
There's
Likert
lots of
scale or
reading material available on the net. You can download this book and start reading. It will give you for all the different kinds of analysis which you think can be a part of your research paper.
okay, sir. Thank you.
Sir, could you please repeat the name of the book, sir?
It is Discovering Statistics Using SPSS.
Okay. Thank you so much, sir.
This book
It's
is
already written on his PPT. Just see the screen. It's already
And
mentioned.
also it is posted in the chat box, so participants can also copy it from the chat box.
Okay,
The
thank
ebook
you.
is available on the net. All of you can download this ebook in the PDF format, right? And you can refer to this book. It's a wonderful book, right? And I'll say that if you really want to have a strong concepts, right, use this book, right?
Yeah, even the PDF link has been shared in the chat box. Thank you, participants. Thank you so much, sir. The next session will begin at 12:30 p.m. I would request all of you to join the session 10 minutes before the scheduled time. Thank you so much.